I pushed stop a little bit too early. Let's go look at y equals e to the x. Is that going to be exponential growth or exponential decay? What is e? E is an irrational number. Can you name another famous irrational number? Pi. Pi is approximately 3.14. What is e approximately equal to?
It's like points.
So let's go to our calculator. Nope, wrong button. Let's go to the calculator. And on your home screen, right above the division symbol is an E. So hit second division, and you get E. Hit enter. E is approximately 2.71828. It's about 2.7. So, very good. It's going to be exponential growth, right? Because the base is bigger than 1. So I'm going to make a note and say that this is exponential growth. Can you go fill in the chart? Well, it's going to be -1, 1 over the base, 0, 1, and 1 the base. What did we say E was approximately equal to? 2.71828, so 2.72. What is 1 over E approximately? 1 divided by E is 0.37. Now if I were to look at it on my calculator, y equals e to the x. Now there's two places to get the e. One was above the division symbol, right? One is above the ln button. And when you do the one above the ln button, it automatically gives you an exponent. Isn't that nice? So e to the x. And what does that look like? Exponential growth. Okay, so you have the points. -1, 0.3, or 0.4, 0, 1, and 1, 2.72. Quick review. What is the domain of this function? All real numbers. What is the range of this function? 0 to infinity. Do you include 0? No. Because what happens at y equals 0? There's a horizontal asymptote. Good. Okay, let's go have fun graphing. Fun. Let's move them and reflect them. What does y equal -2 to the x look like? Okay, what does a negative out front do? Flips it over the x-axis. So before we go there, let's go graph y equal 2 to the x, the parent function. The rule is -1, 1 over the base, 0, 1, and 1 the base. So if I graph that, 0 or -1, 1/2, 0, 1, and 1, 2. Here's my parent function. What do I want to do to my parent function? I want to flip it over the x-axis. So I want to make all the y values negative, right? Do I want to change my x values? No. So those stay the same. But my y values I want to multiply by a negative. So this would become -1/2, -1, -2. Go plot those points. -1, -1/2, 0, -1, and 1, negative 2. The graph of y equal negative 2 to the x looks like that. What is the domain of the red function? All real numbers. What is the range of the red function? Okay, be careful. It is 0 to negative infinity, but which one always has to come first on interval notation?
Negative infinity to 0.
Negative infinity to 0. Always put the smaller one first. What about the horizontal asymptote? Has it moved? It's still the same. Y equals 0. All right, go do number 2. All right, for the parent function, negative 1, 1/2, 0, 1, and 1, 2, right? So we have negative 1, 1/2, 0, 1, and 1, 2. All right, what are we doing when we do 2 to the x plus 3? We're adding 3 to the x. So which way does that move it? You remember when we did translations? It moves it left, right. Correct. It moves it left, 3. So what do you want to do to your x values? You want to subtract 3 from all of your x's. So negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. Do you do anything to the y values on this one? Nope. So you get 1/2, 1, 2. All of these points, all you're doing is moving them left 1, 2, 3. What is that point? Negative 4, 1/2. You're moving this point left 1, 2, 3. What is that point? Negative 3, 1. This point, instead of 1, 2, move it left 1, 2, 3. What is that point? Negative 2, 2. So your function looks like this. Yeah.
So on the last one, we changed the y values, and this one we changed the x values.
You got it. Because this one, all you did is reflect over the x-axis, right? Because of that negative, exactly. So that negative out front meant multiply the y values by negative 1. On this one, you're moving it left 3, so all the x values you subtract 3. Or you can go graph the parent and then just move the points the way you're supposed to move them. For the purple function, what is the domain? All reals. Haven't messed with it. What's the range? 0 to infinity. Haven't messed with it. What's the horizontal asymptote?
0.
Y equals 0. Go do number 3. With number 3, you're doing 2 things. You're moving it 2 different ways. The first way you're moving it is to the right 2.
And then down.
So my x's, what am I going to do to my x's? I'm going to the right 2, so I need to add 2 to all my x values. And then the second thing I want to do, let's not do pink, is to move down 1. So what does that mean to do to the y values? I want to subtract 1 from the y values. So go do your parent function. What were your parent points? Negative 1, 1/2, 0, 1, and 1, 2. Negative 1, 1/2, 0, 1, and 1, 2. There's my parent. I want to take all of those points and move them right 2 and down 1. Right 2, 1, 2, down 1. Right 2, 1, 2, down 1. Right 2, 1, 2, down 1. Now, what are those points? This first point is 1, negative 1/2. Does that make sense? Negative 1 plus 2 is 1. 1/2 minus 1 is negative 1/2. Cool. Everything works like it's supposed to. The second point here
2, 0.
is 2, 0. 0 plus 2 is 2. 1 minus 1 is 0. The last point here is what? 3, 1. 1 plus 2 is 3. 2 minus 1 is 1. It all worked like it was supposed to. Domain and range. Domain of the purple function is what? All real numbers. The range of the purple function, be careful, we've moved it down 1. So it's no longer 0 to infinity, it's going to be negative 1 to infinity. Do we include negative 1? No. The horizontal asymptote, we shifted down 1, so it's now going to be at y equal negative 1. On your calculator, y equals, clear that out, 2 to the x plus 3. Make sure you arrow down back to the base, minus 1. Did I do x? Should have been x minus 2. Why'd y'all let me do that? Y equals x minus 2. Does that look like our graph?
Yeah.
Goes through 2, 0. Cool.